Hello everyone. In my last video, I have discussed about how to integrate proper rational function. So already you know the method of decomposition is applied to have the partial fractions for that proper rational function, and once we have the values of the constant, then we can easily integrate that proper rational function by using the method of U substitution or some other techniques. Okay, so in this video we will focus on how to integrate improper rational function. So what does it mean? You already know that the definition of improper rational function is if the degree of numerator is greater than or equal to the degree of denominator, then that rational function is called the improper rational function. So let's start. So this time we have a rational function, that is the ratio of two polynomial functions, p of x and q of x. So suppose we have to integrate that improper rational function. So this time we are discussing about improper rational function. So remember, this function capital R of x is an improper rational function. So if we have one improper rational function, then the method of decomposition that we have learned in our previous video, so that will not work directly. First of all, we have to convert this improper rational function to proper rational. Once we can convert this improper rational function to proper rational, then we can apply the method of decomposition. I am repeating again, if we have an improper rational function in this integrand, so we can't apply directly the method of decomposition. So whatever we have to do, we first have to convert that improper rational function, we have to convert this improper rational function to proper rational, then the method of decomposition will be applied. So this is the prerequisite. We have to convert this improper rational to a proper rational. So now question is arising, how we can convert improper rational to proper rational. Okay, so we can convert an improper rational to a proper rational by using long division method. So here I am introducing another new technique, that is called long division method. It is not actually the new technique. You have the idea of long division method from the very childhood. Okay, so let me discuss about long division method at first, then we will move to improper rational function again, and you will see how long division method can be applied to convert an improper rational function to a proper rational. So after we have the proper rational, then things are same as before, whatever we have done in our last video. Okay, so let's discuss about long division method. So what is a long division method? we may have an improper rational. Let's say it is 8x squared negative x positive 2 over 4x squared negative 1. I have given one function that is a rational function. This is obviously a rational function since it has polynomial in numerator and it has another polynomial in denominator, and we are getting the ratio of these two. So this is a rational function. Now let's recall this definition. We have to check the degree of numerator and the degree of denominator. If the degree of upper part or numerator is greater than or equal to the degree of denominator, then we can say that that rational function is actually improper rational function. Okay, so here we can see that in upper part the degree, that is the highest power of this polynomial, is 2. In lower part the degree is also 2. So since we have the same degree both in numerator and in denominator, so we can say that this rational function is an improper rational function. Okay, so if we have an improper rational function, then we have to know how we can convert this improper rational to proper rational, because if we have to integrate this type of improper rational function, then calculations will be too difficult. Okay, so for this we have to apply long division technique. So here I am going to discuss about the long division technique. So long division method means here we have 8x squared negative x positive 2, and we are dividing this function, this upper function, by 4x squared negative 1. So from your childhood you know that we can divide by this way. Let me recall all the things at first. You know that this part will be divisor, this part is dividend, it will be quotient, and the remaining part will be the remainder. You will understand if I show you one example here. Suppose we have 7 over 2. So what we can do? We can divide 7 by 2. So if we multiply 3 with 2, we will get 6 here. After subtraction, we will get 1. So this inside part is called the dividend. This one is called the divisor. This answer is called the quotient, and this one is called the remainder. So I am just discussing about this thing. So this is called division technique. So here we have number 7 over 2, but whatever concept we have here, these are polynomial functions. So again we can apply the same technique. This is the dividend, this one is the divisor. Here we will get the quotient, there may be a remainder. So just to perform this division, what we have to do, let's discuss. So at first, just for your betterment, I am removing this part. Now you can easily understand that we are dividing this function by this one. So first of all, just to perform this division, we have to focus on the leading term of dividend and the leading term of the divisor. Leading term means the term with highest power of x. Here you can see that x squared is the highest power. Here x squared is the highest power. So that's why I am saying this one is the leading term. And similarly, this one is also the leading term. Okay. So at first, we are focusing on the leading terms. Now, what we can do? We need a similar term here. Here we have 8x squared and we just need 8x squared here. For this, what should be multiplied to get this one? So we have to multiply. If we multiply 2, so 2 times 4x squared, that will give us 8x squared. I am repeating again. If we multiply 2 with this part, then we will get 8x squared, that is same as this one. Okay. Now you can see that we have multiplied 2 with the leading term of divisor. We have also another term. So let's multiply -1 with 2. So we are getting -1 times 2, that is -2. So this part is for x square column, this is for x column, and this will be for the constant column. Okay. So since we are getting 2 times -1 as -2, so that means it will be here under constant part. Now what we have done for this division, we have subtracted 7 minus 6. So same thing will be done here. That means let's subtract this one, and now we have to bring the remaining parts here. So what we can say here, it will be, actually we have here plus 0. Okay, so that means we will get -x and 2, and here we have +2. So that means we are getting +4. So you can see we have divided this function by this one. So there will be a question that should we repeat the process again? Should we focus on the leading term again? So the answer is calculation will be stopped if we get the less degree than the degree of divisor. What I have said, that if we get the less degree in the remaining part, then the degree of the divisor, then calculation will be stopped here. Okay, you can see that whatever part we have found, x power 1, that means the degree is 1, and in divisor we have degree 2, so that means this is less than this one 2. So that's why we are stopping our calculation. So finally what we can say, we can say that this is the divisor, it is the quotient, the middle part is dividend, and this remaining part is called the remainder. So whatever we had previously, we had 8x squared negative x plus 2 over 4x squared negative 1, which was an improper rational function. But now we can express the same function by this way. That is, I am writing the part here. Try to understand. We can write this rational function as quotient plus remainder by divisor. This is a formula how we can express any improper rational function to proper rational. If we check this one, automatically we will get a proper rational function here. So let's do the same thing. Our quotient is 2. Here we can see plus remainder is negative x positive 4. Our divisor is 4x squared negative 1. So we can see that whatever function we had before, 8x squared negative x positive 2, 4x squared negative 1, is now expressed by this way. And automatically you can see on this part that here we have x power 1, here we have x power 2. That means the degree of numerator is 1, the degree of denominator for this part is 2. So 1 is less than 2. That means it is obviously a proper rational function. So this is how we can express any improper rational to a proper rational by using long division method. So now we can understand that long division is just going with your previous studies. Okay, so you don't need to worry about that one. So we are using the same technique whatever you have learned in your previous days. So what I have written here, I have mentioned one formula, that is any improper rational function can be expressed as quotient plus remainder over divisor. For quotient I am writing the short form Q plus remainder, let's say remainder REM over divisor. Think about this part, 7 over 2. The same condition will hold for this one. That is 7 over 2 can be expressed as quotient. So here quotient is 3 plus remainder. Remainder we have found it is 1 and the divisor is 2. So we can see that 7 over 2 is now expressed in this way, 3 plus 1 over 2. If we combine 3 plus 1 over 2, you can check by your calculator, you can verify, you will get 7 by 2 again. So that means we can express any improper rational part to proper rational. So the formula is rational function is equal to quotient plus remainder over divisor. That means after long division we are getting this part. If we combine this one, we will get again 7 by 2. So same technique is applied for this rational function, for this improper rational function. So we have, if we combine this one again, we will get this part back. Okay, so I hope you have understood the division technique. Now we are going to focus on how we can integrate improper rational function. So I am generating one formula here, that is R of x, that is an improper rational function. We are not discussing proper rational here, we are discussing about improper rational. So R of x can be expressed as quotient plus remainder by divisor. You can express this function by using division method. Now our focus is on integration. So suppose in our given question we have to integrate this rational function which is of improper rational, which is of improper type. So just to integrate this rational function, what we have to do? At first we have to apply division technique so that we can express this rational function into quotient plus remainder over divisor. So if we have to integrate this one, then integration will be distributed with quotient and this one. That means we can easily find the antiderivative for this integral, and for finding the antiderivative of this part we can apply the techniques that is called the method of decomposition. That means obviously after using division technique you will get a proper rational, and you know how we can integrate a proper rational by using division technique. We have solved so many problems in our last video. Okay, so first target is to convert the improper rational to proper rational by using long division technique. And remember, the formula is quotient plus remainder by divisor. So if we have to integrate that improper rational function, we can integrate the quotient part, we can integrate then remainder over divisor. So just to integrate this one, we have to apply the techniques that we have learned in our last video, that is the method of decomposition. And you know that proper rational can be decomposed by these three types. These are the three basic types, and type 4 is the combination of type 1, type 2 or type 3, whatever. Okay, so type 1, that means if we have the linear factors, all factors will take a constant. If we have this one and this one, if we have suppose x negative b whole squared, then x negative b will come with b, and then x negative b whole squared will come with c. Similarly we have type 3, that means if we have quadratic part here, x squared negative b, so x squared negative b will take bx plus c. Just we are recalling all these things because finally after long division we will get a proper rational function, and we know from last video how we can integrate proper rational function. So let's take one example, but before that I am again showing you the algorithm what we have to do here. So we have an improper rational function, at first we have to convert this to proper rational by using division technique, which is called long division technique. Then we can apply the formula, that is capital R of x, that is improper rational function, is expressed as quotient plus remainder by divisor. So finally integration of this part will be this and this, and then we have to decompose this proper rational by using the method of decomposition. It may be of type 1, type 2 and type 3. So let's take one example. Let's say we have to integrate. Let's take a complicated rational function which is of improper type. 2x cube plus x squared negative, let's say 7x negative 3. I am taking a function randomly, and in denominator we are placing, suppose we have x squared negative 4, so we have to integrate this function. Now we can see that this is of improper rational type. That means it is one kind of improper rational function. How we can understand this one? In upper part we have degree 3. That means from numerator we are getting degree 3, but in denominator we have degree 2. So degree of numerator is greater than the degree of denominator. So obviously this function is called improper rational function. Now if we try to integrate this improper rational function, you can understand that it is not so easy. Okay, so just to find the antiderivative for this integral, what we can do, we can convert this improper rational function to proper rational function by using long division technique. So we are going to use now, so using long division process or technique. So using long division technique we can divide this function by x squared negative 4. That means we can divide the upper part by lower part. So here we have x squared negative 4 and 2x cube plus x squared negative 7x negative 3. Now we have to focus on the leading term of dividend and the leading term of the divisor. So we need here a same term. Here we can see the leading term of dividend is 2x cube. We also need a same term here just to perform this division. So if we need 2x cube here, so with the divisor what we have to multiply, you can think about, here we have x squared, we can multiply 2x, so 2x times x squared we will get 2x cube. So instead of writing the result here, we can write the result on this part. So 2x times x squared is giving us 2x cube. At the same time, don't forget about this one, we have to multiply 2x with negative 4 also. So we will get negative 4 times 2x, we will get negative 8x. So you can see negative 8x. Let's take x column, this is x column, so here we can place negative 8x. Now the next step is subtraction. Let's use subtraction and try to simplify this one. So what we are getting, x squared, now negative 7x, positive 8x, we are getting only positive x, and from this part we are getting negative 3. But this one and this one are cancelled because here we have 2x cube, here we have negative 2x cube. Now you will be confused that should we stop here or should we proceed again. I have mentioned earlier that you have to continue the process until we get the less degree here than the degree of divisor. So what does it mean? Here we can see that for this part we have the degree 2. Degree means highest power of that polynomial. So here we can see that the degree is 2, and here we have also the same degree. So since this is same, we can say that it is not less than this one. So calculations will be continued. That means we have to repeat the same process again. We can stop only when we have the less degree here than this one. So now again the same process will be applied. We have to focus on the leading part, and we have to focus on the leading part of divisor. So now, just like the previous part, we need a similar term here. So just to get the similar term x squared, what part should be multiplied with this one? You can easily figure out. We need x squared here, so we can multiply 1 times x squared, that will be x squared. So instead of writing 1 here, we will write 1 here, so positive 1. If we multiply positive 1 with x squared, we will get x squared. So we have written x squared here. At the same time, don't forget to multiply negative 4 with positive 1. So negative 4 and positive 1 is actually negative 4. So that means we have to write this one in constant part. Now the next step is to subtraction, is to use subtraction method. So here negative, positive, if we subtract this and this, we will get 0 for this one. Okay, no need to write 0. Now bring down the remaining parts. Here we have x, negative 3, positive 4, we are getting positive 1. Now we have the remaining part, this one. Again we will check whether we have the less degree than divisor or not. So this time you can see that the degree for this remaining part is 1, but the degree of divisor is 2. So obviously 1 is less than 2. That means we have found less degree than divisor. So we have to stop here. That means finally we are done. So let's figure out that it is divisor. It is the quotient, and this part is the remainder. So this improper rational function now can be expressed as this way, that is quotient plus remainder over divisor. So let's write r of x is equal to quotient plus remainder over divisor. So r of x is equal to 2x cube plus x squared negative 7x negative 3 over x squared negative 4 equal to, so what result we have found for quotient? Quotient is, this is q 2x plus 1. So let's write 2x plus 1 plus, this is our quotient, plus a remainder. So what is our remainder here? It is x positive 1. And what is our divisor? X squared negative 4. So we are using this technique. Improper rational function is equal to quotient plus remainder by divisor. Now automatically you can have a look here. It must be a proper rational. So here we can see that in numerator we have degree 1 and in denominator we have degree 2. So degree of numerator is less than the degree of denominator. So this is now proper rational. So we can easily decompose this proper rational function. Now in our given question, what we have to integrate this improper rational function. So integration will be, let's figure out again, integration of this rational function will be integration of quotient and integration of remainder over divisor part. So I am writing the same thing here. Integration of this improper rational is equal to integration of quotient and integration of this part. So the result of the left side is equal to the summation of these two integrals. First of all, we can easily solve this integral. So I am writing directly integration of 2x. So at first 2 is constant. I am writing here integration of x power 1. It will be x power 2 over 2 plus integration of 1 in terms of x is actually x. So already we have done this part. That means this integral can be solved easily. But the question is how we can solve this. That is x plus 1 over x squared negative 4 dx. So we don't need to have any tension for this. Already it is in proper rational form, so we can easily integrate by using the method of decomposition. So let's write again. If we simplify 2 over 2, that is here we can cancel this part. So here we have just x squared plus x, then positive, let's say this is I. So since we have two indefinite integrals on right side, so this will take a constant c1, this will take another constant c2. The sum of these two constant will be again a constant. So no need to write c1 and c2. We will just place a constant c. So finally we are able to convert this improper rational to quotient plus proper rational part, and our next target is to find this I. Okay, so you will get the result here. That means integration of 2x cubed plus x squared negative 7x negative 3 over x squared negative 4 dx is equal to x squared plus x plus this integral plus c. So let's say this is equation 1, because after having I we can input the function or antiderivative here, we will get the fulfilled result. So now let's find I. So I equal to, we have considered x positive 1 over x squared negative 4. Now it is going with our previous section, that it is of proper rational function and it may be of any of the types, type 1, type 2, type 3. So let's check. This function is proper rational now. So just to integrate this one, what we can do at first, we can apply the method of decomposition. But before that, you must know that we must have to have the factor from here. So what we have here, we have just x squared negative 4. So let's try to factor out x plus 1, x squared 4 can be written as 2 squared, so x squared negative 2 squared dx, and you know that x squared a squared negative b squared is equal to a plus b times a negative b. So if we continue this process, then we will get x plus 1 over x plus 2 x negative 2, x squared negative 2 squared, x plus 2 x negative 2 dx. So now we can see we have the factor form. This is I. So in next steps, we have to decompose this inner function x plus 1 over x plus 2 x negative 2. We don't need to focus on the numerator, we have to focus on the denominator. You can see all these two factors are of linear factor. Okay, so here we have x power 1, x power 1. That means it is going with type 1, x negative a, x negative b. X negative a will take a constant a, and x negative b will take a constant b. So we are doing the same thing here. That means let's mention the type. It is of type 1. So at first x positive 2 and the second factor is x negative 2. We are writing x positive 2 and x negative 2. So since all these two are linear factor, or it is going with type 1, so x positive 2 will take a constant a and x negative 2 will take a constant b. Now recall our previous video, what we have done here. In next step, we have to multiply the term that is in the left side denominator. So we have to multiply. So multiplying x positive 2 x negative 2 on both sides. So if we multiply x positive 2 x negative 2 here, so this part and this part will be cancelled. We will just have x positive 1. Let's write x positive 1 equal to, if we multiply x positive 2 and x negative 2 here, so then x positive 2 will be cancelled. So just we will get a times x negative 2. Similarly, if we multiply x positive 2 x negative 2, so x negative 2 will be cancelled. We will get b times x positive 2. So finally we have established one relation. From this relation we can find the value of a and b. That means we can find these constants a and b. This is our target. So what we can do here, just like the previous videos, we can input x equal to, at first let's say we want a. For this we can input x equal to -2, -2, +2, it is becoming 0, so this part is vanished, we will get a automatically. So we are going to input the value of x. So let's locate x. These are the positions where we have x. So input x here, that means in left side -2, +1. Right side will be -2, -2 plus b times -2, +2. So what we are getting? We are getting -1 equal to -4a plus this part will be 0. So here we are getting -1 equal to -4a. That means a equal to 1/4. So we have found the value of a. Let's apply the same technique. Let's input 2 now. So if we input x equal to 2, from this part 2 +1 equal to a times 2 -2 plus b times 2 +2. So we are getting 3 equal to 2 -2 is 0 plus 2 plus 2 is 4, so 4b. So we have 3 equal to 4b. That means b will be 3/4. So our target is fulfilled. That means we have found a and b. Now let's come from this one. We can input a and b here. Then we can integrate. So x plus 1 over x plus 2, x -2. So that means we have x plus 1 over x +2, x -2. That is equal to a over x +2 plus b over x -2. Now since we have the values of a and b, let's input the value of a here. So a is, we have found a as 1/4 and b is 3/4. So we have to integrate this function. So integration will be here and here, and we have already considered this integral as I. So let's try to find the antiderivative for these two integrals. So 1/4 is constant, so we are pulling out 1/4. We have 1 by x plus 2 dx. Again 3/4 is constant, so 3/4 is pulled out before this integral part. So I hope you must have watched my last video where we have established that if we need to solve these integrals, we can apply the technique of U substitution method. This one. But we know that I am not showing all these steps here. You know that the formula is integration of 1 over x dx, that can be written as natural log of modulus x. So similarly, we can say if we have integration of 1 over x positive a dx or x negative a dx, then we can write natural log of x positive a or negative a. So we can apply u substitution method, or we can directly apply this formula. So we are getting natural log of modulus x plus 2 for the first integral, and here we have 3 over 4, and now again we can extend this idea. We can use this formula, that is if we have 1 over x negative a dx, then the formula says that the result of this integral will be natural log of x negative a. So for this one, 1 over x negative a, it will be natural log of modulus x negative 2. So this is our final result for I. So this is done. Let's come back to our main question. So we have actually integration of this improper rational function, and we have applied long division technique. Then improper rational is equal to quotient plus remainder by divisor. Then we have integrated over quotient and for this proper rational part. So finally we have generated an equation that is equal to the integral of the main function. So we are going to write this one. That means here we have x squared plus x plus I plus c. Just we need to input I. You don't need to show all these steps, just I am writing the result finally. We have the function 2x cubed positive x squared negative 7x negative 3 over x squared negative 4 dx, that is equal to what we have written in equation 1, that is from equation 1 we have x squared positive x positive I, and since we have this indefinite integral, so we are using a constant plus c. So x squared positive x positive. Now input this I. So I is equal to 1 over 4 natural log of absolute value x plus 2 plus, you can see, 3 over 4 natural log of absolute value x negative 2. So this is our result for this integral. I hope you have understood the concept. So in my next video we will focus on how to integrate improper integrals, not improper rational function. How to integrate improper integrals, that are different things. Okay, so we have completed up to this part for now. Thank you.